Okay, next up we have Carol Barrie and Tibby Harvey from the RHS talking about AI for environmental resilient planting from herbarium to home garden. Now, poor Carol's plane was cancelled, and so she has stepped up and is going to do it online. So please bear with us while we sort out the tech. Okay.
Fantastic, thank you. Okay, good afternoon, everybody. My name's Carol Barrie. I work for the Royal Horticultural Society as a project manager in science and collections. My talk today is on AI for environmental resilient planting from herbarium to home garden. I am lucky enough to work with many areas. As a project manager, I work with the herbarium team, plant identification and botany, environmental horticulture, and the curators of the living collections as well. So it's a real interdisciplinary role, which gives a fabulous mix of topics, which sort of is fascinating on a daily basis. So if you move on. Can you move on the slide? Thanks. So my talk today will look at the unique value of herbarium collections for environmental horticulture, and show how data-driven plant selection can empower industry, government, and millions of gardeners to contribute meaningfully to climate resilience and biodiversity recovery at a national scale using AI technology. And the picture there is of our herbarium based at Wisley Garden, the RHS garden. So if you go on to the next slide, I'll give you some more information about our herbarium there. So originally based in the iconic old laboratory at Wisley Gardens since 1916, the RHS herbarium is now housed in a purpose-built state-of-the-art facility at RHS Hilltop, home of gardening science, RHS Wisley Gardeners. It contains over 100,000 accession plant specimens, 45,000 photographic slides, and 8,500 photographic prints, as well as paintings and collecting trip notes. It's the largest herbarium dedicated to preserving UK garden plants. And the herbarium also provides an aid for identification, where we have an advisory service for members at the RHS, and research into older cultivars, particularly Plant Heritage National Collection holder. More recently, though, it is an important and unique image source for AI. Next slide, please. So the Royal Horticultural Society is strengthening its commitment to helping the nation's gardeners enhance environmental resilience through a Plants for Purpose programme, which will research, identify and recommend cultivated plants that provide environmental benefits for humans and the planet. Very much our focus is on right plant, right place, right purpose. Our science teams are carrying out pioneering research to combat global challenges such as climate change, biodiversity loss, and increased urbanisation. The project will identify a wide diversity of plants and make them accessible for all to use. And the picture there is our facility at Hilltop, which holds our herbarium and all the science labs and teams working with them, including our library and advice teams. We're very keenly looking at some of the discussions around native plants and non-native plants, where there are there's quite a lot of drive to continue to plant native plants so we don't lose them. However, there is very much a need to be able to bolster their resilience against climate change with cultivated plants, where if you have a mixture, you can vastly strengthen their robustness against climate change, as well as pest and disease. So we're very focused on proving the sort of benefits of cultivated plants alongside natives to show their value. Next slide, please. So the ecosystem services research then is identifying ecosystem services of our garden flora, and is crucial to alleviate stresses, particularly in harsh urban environments. It isn't feasible to exhaustively test for the various ecosystem services of the estimated 400,000 plants considered to be in cultivation in the UK. AI machine learning approaches will be key to overcome this issue, helping researchers identify common traits in taxa that are currently known to provide ecosystem services. This will not only speed up analysis, but also help to identify and prioritise taxa for ecosystem service research into the future. And the picture there shows down at our research field an experiment on garden trees, which looked at cooling services and the effects of different leaf colour. In the same piece, we also looked at other ecosystem services like carbon capture of smaller garden trees and evapotranspiration rates for water use and flood mitigation and things like that. Next slide, please. So we are now collaborating with the University of Nottingham, which is harnessing machine learning models trained on digitised herbarium specimens from the RHS's herbarium. Nottingham's core research focuses on machine learning and artificial intelligence approaches for complex bioimaging problems. And by combining these AI-derived insights with the horticultural and botanical expertise alongside scientific research, the project is identifying cultivars capable of delivering measurable benefits under a range of site conditions. So very much a joint piece using University of Nottingham's computer science department and their knowledge and experience alongside our botanical knowledge and horticultural experience at the RHS. Next slide, please. This picture shows that, so there's the original herbarium specimen there of Stachys byzantina, and when you look more closely and enlarge it, you can actually see the fine hairs on the leaves and other such traits like scales and rough surfaces. And once trained on these traits, the AI can develop software through which we can search through the collections and highlight herbarium specimens that share those traits. We know that the level of quality of the images we have allows, really clear view and is able to be enlarged numbers of times so that we can actually see these details in close-up. Next slide, please. The digital plant images are split into multiple tiles, so every specimen image is split up into hundreds of tiles. and the machine learning categorises these by features of interest. Next slide, please. The image data source, we have 50,000 digital images are now uploaded onto the tool, and it's being trained on those. And so the current training set is 3.9 million tiles. It takes the AI tool around 10 hours to look through the whole set one by one. Next slide, please. This picture shows how the smaller tiles then are all classified by features and grouped together. And this is a 2D view of what the network sees, but the actual network group is a 500 by 2000 dimensional space. So the picture is a huge simplification, but allows us to see the sort of different plant features are correctly being grouped into the different categories. Next slide, please. This is a picture of the tool that demonstrates on the left there. We've picked out a couple of features from one image, and we've asked the tool to search through all of the thousands of images to find similar traits in other specimens. And you can see on the right there, it's pulled out a number of similar looking pieces. And this allows us to identify more plants that we're able then to trial further to see if they deliver the same ecosystem services. Next slide, please. So this is Dr. Michael Pound at University of Nottingham. Has just he stated the collection is unmatched in its quality and diversity, offering image resolution and clarity beyond common public data sets. So it's really useful for him to have that quality. Next slide, please. So the results and plant recommendations will be made freely available on the RHS website using our RHS Finder plant and on our RHS Grow app. So we're hoping to be to enable all gardeners to be able to access evidence-based guidance to support climate positive planting decisions for our planet, our wildlife, and our human population. Next slide, please. So in summary then, the RHS herbarium exists as an essential national asset, giving the UK the evidence it needs to choose what to grow for people, nature and climate resilience. Forms a vital role in the computer science PhD project at Nottingham University. And the expansion of the herbarium and digital collection will provide a richer database for machine learning approaches. And we're looking to start collecting a 2-year programme to start collecting specifically in the southwest of the UK so that we can look at plants that are more resilient to the UK's future climate. Next slide, please. And finally, this is just a picture of the current network on the tool, which visualises the entire herbarium in one view. And it's actually got 4 million tiled images in that one view. And I think it looks like a murmuration of herbarium specimens. Last slide then, please. To finish, just to say thank you very much to everybody involved that allows this to happen, because it's very much a joint venture, and also to our specimen collecting, curating and digitising teams at the RHS. Without them, we would not be able to take on this venture. And that's me. Thank you very much for listening.
Okay, thanks. That was a great talk. Really interesting. Sorry. Does anyone have any questions for Carol?
Hi, that was super interesting. Thank you so much. I was just wondering, when you were saying that the AI is using these kind of visual images to identify plants that have kind of ecosystem benefits, is that purely through visual traits? And is there like a tagged bank of what those traits are? Or is there also kind of associated metadata with more information that the model can kind of take into consideration?
It is in the main physical visual traits, which we're identifying through our scientific research and botanical knowledge to identify, you know, very small, tiny differences between plants and different shaped flower heads and stamens and things like that. Yes.
Carol, I was just wondering if you had any plans to share your amazing software and what you've been doing with the rest of the community, and whether we could all use it, please.
I expect there will be a possibility at some point. The PhD is about 18 months in now, and so it's got another couple of years to go. And then I expect Lily will publish her findings, and then but the RHS does usually share everything for everybody to use freely. So I expect so, but maybe not for a couple of years.
Okay, super. Right, has anyone got any last questions for Carol? No? Well, Carol, thank you so much in the face of adversity for being with us today. We really appreciate it. It went down brilliantly, and we can see you and we hear you, and it was great. So thank you so much.
Brilliant.
Okay.
Lovely. Thank you. Bye-bye.